Dear students, today's topic plastics. So in this chapter we studied about synthetic fibers. The next topic is about plastics. So when we discuss about plastics, we know that plastics play an important role in our day-to-day life. So we come across a lot of things which are made up of plastics. So if you look around us, we can see that many of the things like they're made up of plastics, like bottles, bags, brush, pens, comb, and so many things are made up of plastic. So we can see that plastics play a very important role in our life. So in this session we will learn about different types of plastics and what are the different characteristics of plastics, and the chemistry behind plastics, etc. So the introduction: plastics are synthetic materials. The first point is that these plastics are not obtained from living things. They are not natural things. So plastics are synthetic materials which are made from chemicals, and generally we can say that the plastics can be easily shaped and molded into any form. So we can change the shape of plastic, so we can make the plastic in any shape. For example, in this figure, this plastic material is of rectangle shape, but this is in another shape. So this is in round shape. So we can mold the plastics in any shape. Then plastic is a synthetic material. At the same time, it is a polymer like synthetic fiber. So we studied about the fibers, nylon, rayon. All these fibers are polymers, and these polymers are then made up of small units called monomers. Similarly, plastic is also a polymer, and its polymer is made up of small monomer units. Then we will talk about the different types of monomers. So in this case we can see that two figures are given, and that is different arrangement of monomers in the plastic. So first one, linear arrangement of molecules. Molecules means the small units which form plastic, that is monomer. Then cross-linked arrangement of molecules or monomers. So these are the two different arrangement of monomers that we can observe in the plastic. So we cannot see this arrangement, but when you look at a plastic material, it may be bottle, comb, pen, or any plastic article, so actually it can be made up of any of these two arrangement of monomers. The monomers of plastic can be any of these. That is in the first one, linear arrangement. What do you mean by linear arrangement of monomers? The monomers will be here, each box is monomer. First monomer, second, third, fourth, fifth, then 6, 7, etc. Similarly, second row, that is in this case the monomers are arranged line wise like this. This is the first line, then second line, third line, fourth line, like this, linear. So this arrangement is called linear arrangement of monomers. And this type of long linear chains of monomers especially present in which type of plastic? Flexible plastic. For example, we can see that the toys for kids, it is very flexible, and many of the bottles can be flexible. So these flexible plastics are actually made up of linear arrangement of monomers like this. So these are not the actual number of monomers. So like this, monomers are large number of monomers arranged line wise. This is the linear arrangement of molecules. Then another type is cross-linked. So what is the difference? In cross-linked, you can see that this linear arrangements are then connected like this. There will be linkings like this. In linear arrangement, only lines, linear, but in cross-link will be like this. You can see that the interlinks between two lines. This is called cross-linked chains. So in cross-linked chains monomers, in such case, if the monomers are of a cross-linked chain, then the plastics will be rigid. So this linear arrangement of monomers can be observed in which type of plastics? Flexible or very soft plastics. But this type of cross-linked monomers are in which case if the plastics are very strong and rigid, such plastics are made up of this cross-linked arrangement of molecules or monomers. So this is the two types of arrangement of monomers. Then another point, most of the plastics, it can be flexible or rigid. We will see the preparation of manufacture of the plastics. So from where do we get these plastics? So these plastics are actually made in chemical industry, plastic industry, using some chemicals, and these plastics are then remolded into different shapes in the form of different articles. So many of the plastics, most of them are made from some liquids extracted from crude oil. So actually this plastics, most of the plastics are obtained, its origin, we can say that it's from crude oil. So we know that crude oil, what is crude oil? Crude oil is it is also called petroleum. It is a fossil fuel, and it is made up of large amount of many other ingredients, and from this crude oil we will get diesel, petrol, kerosene oil, and many other products. And some liquids can be separated from this crude oil. Using this liquids we make different products like fabrics, fuels, plastics, medicines. So this plastics, many of the plastics are also prepared from the liquids which separated from crude oil. So this is the synthesis of plastics. Our next topic, types of plastics. So mainly there are two types of plastic. First one, thermoplastics. Second one, thermosetting plastics. Now we will see the difference between these two. So from these two we can see that there is a word thermo. Thermo is common in both the case. What do you mean by thermo? Thermo means it is something related to heat. Thermo means it is related to heat. That means the classification into thermoplastics and thermosetting plastics, it is based on the heating property of the plastics. So first of all we will discuss the difference. First we will see what you mean by thermoplastic. A thermoplastic is a plastic that becomes soft and moldable when hot and sets into a rigid form when cold. It can be molded repeatedly after heating into desired shapes and sizes. So this type of plastic is called thermoplastic. So we can say that thermoplastic is the one that becomes soft and moldable when you heat it. So suppose if you heat thermoplastics, what will happen is that thermoplastic, when it becomes hot, it will become very soft, and it moldable means it changes its shape and it can be molded in any shape. So suppose if you have thermoplastic like this, so mainly the comb or pen or toys, then the polythene bags, PVC pipes, all these are examples of thermoplastics. Suppose if you have a thermoplastic like this, suppose the thermoplastic article is of this shape, like rectangle shape. If you have a thermoplastic material like this shape, and if you heat it, that is we want to heat it, if you heat this thermoplastic, what happens? It will become very soft. So when you heat it, it will become soft and it will melt. It will melt. Melt means this will be changed into liquid form. So we know that this plastic, this thermoplastic is in the form of solid, very hard. But when you heat it after some time, it becomes soft and it will be undergoing melting. Melting means we will get a liquid form, like that is called melt. So like this picture. So if you heat the thermoplastic, it will become like this. It will become very soft and it will melt like this. And after it changes into liquid form, what we can do, we can change this plastic melt into any form. It can be moldable. It is can be molded in any shape. So now we have the liquid form of this plastic, and now we are going to using this melt. So we are going to make another toy or another article like this. Suppose like this. If I make a shape, an object like this shaped object using this melt. So this is called what? Moldable when hot. So when you heat the thermoplastic, it will melt and becomes very soft. Using this melt, we can mold it. It will be moldable when hot. Using this melt, we can make another shape. We can make another plastic object. So this is the specialty of thermoplastic. And when it is hot, say when it will become very soft. That's why using this melt we are able to make another plastic object. But after some time, after making this object, after some time we know that this object will become very cold. And when it becomes cool, what happens? It sets into rigid form. It will be rigid. So when it is hot, when we heat it, it becomes soft and it is easy to change the shape. But once you made it in a shape, and after that, if it becomes cool, it will become very rigid. At that time, it is not soft. When it becomes cool, when it cools, what happens? This plastic automatically sets into this particular shape, and also it become very rigid. It is not soft. It will become very strong. It is not soft, and it will become very thick and strong. So this is the speciality of thermoplastic. That is, if you heat the thermoplastic object, it becomes soft, and using the liquid melt of that, we can make another plastic object. And when this new object cools, it becomes rigid and strong. Then next point is that it can be molded repeatedly. That means it can be remolded. Means if you heat this new object, new plastic object again, if you heat it, what happens? It is also thermoplastic. Then it will also melt and becomes very soft. And now using this melt, you can make another plastic object. That is, it can be molded repeatedly after heating into desired shapes and sizes. So we can remold it. We can change the shapes and we can change the size of the thermoplastic material when you heat it. So this is the specialty of thermoplastic. Now we will see some examples of thermoplastics. First one, polythene. Polythene is commonly used thermoplastics. It is used for making polythene bags like this. Then next one, PVC. PVC, its full form polyvinyl chloride. And this polyvinyl chloride plastics are made up of pipes. So that's why these pipes are generally, we call it PVC pipes. So PVC plastics are used for making pipes. Next one, polystyrene. For example, these vessels are made up of polystyrene. So all these objects, we can see that when you heat it, it will become soft and forms a liquid melt, and it can be remolded again and again. So this type of plastics is called thermoplastic. Then we will talk about second type of plastic, that is thermosetting plastic. And we can see that it is just opposite to that of thermoplastic. That is, it is a plastic which can be molded into desired shape only once. Once set, it cannot be remolded again. So suppose if you have an object made up of thermosetting plastics like this, if you heat it, it will not change its shape, it will not become soft, it will not undergo melting. But in the case of thermoplastic, when you heat it, it becomes soft and we can change its shape. But thermosetting plastic, once it gain a shape, you cannot change this shape. That is, they are comparatively harder and stronger than thermoplastic. So in other words, we can say that they are resistant to heat. See, if they don't undergo any changes, if they don't change the shape or don't become soft when you heat it, that means they are heat resistant. So if they are exposed to heat, no changes takes place. They cannot be remolded, they cannot change their shape when you heat it. And also we can say that some are electric resistant, that is, some are insulators, and some thermostatic plastics are insulators, means when they exposed to electricity, they do not conduct electricity, they can resist electric current. So this type of plastic is called thermosetting plastic. That is, if when you heat the thermosetting plastic, it will not change its shape. That is, which can be molded into a desired shape only once. So if you have a thermosetting object, you will not be able to change its shape by heating, and we cannot remold it. So this type of plastic is called thermosetting plastic. Then some examples of thermosetting plastics. First one, bakelite. Second one, melamine. Bakelite is mainly used for making electrical appliances coverings, and also used for making switch. For this, electric switch is made up of bakelite. So why? Because this bakelite is exposed to electric current, and this thermosetting plastic bakelite is an insulator, so it will not melt. And melamine is mainly used for making kitchen vessels, plates, dinner sets, etc., because they are exposed to heat. And if you use thermoplastic, see, this is made up of thermosetting plastic, that is melamine is used to make this type of plates. And suppose instead of this melamine, if you use any thermoplastic, what will happen? These plastics, when they expose to, when we serve hot food in this plates, what will happen? If it is thermoplastics, they will become hot and melt, and it will become soft and it changes its shape. Then it will not be useful. But instead of that, if here we use melamine, a thermosetting plastic, it is heat resistant. When you heat it or when it is exposed to heat, nothing will happen, it will remain its shape. So this type of plastics is called thermosetting plastics. Then next topics, properties of plastics. So we have seen that many of the objects, articles which are made up of plastic, and we can say that instead of wood or metals, we use plastics in our day-to-day life. So more than wood or metal and other objects, we use plastics. So what is the reason behind it? Why do these plastics become very popular? So what is the specialty of plastic? So what are the reasons behind it? What are the characteristics which cause the popularity of plastics? We will see about that. First one, resistant to chemicals. Plastics are resistant to chemicals and do not get corroded easily. They are used to make packages for storing chemicals. So they are mainly resistant to chemicals. So that is, they do not react with chemicals or water or air easily, and they do not get corroded, they do not get damaged easily. But instead of that, if you use metal, see, many of the, instead of plastic materials, if you use metal objects, metal vessels, etc., we can see that this metal can be damaged after some time. And if you use wood instead of plastics, it can be damaged. So due to their contact with the atmosphere and environment. But if the plastic materials, if the materials are made up of plastics, we know that they do not react with water or air or other chemicals, or they do not get damaged easily. So this is the main attractive property of plastic, is that they do not react with chemicals and other substances. So because of that reason, we can use this plastics for storing chemicals or medicines, because they do not react with chemicals or medicines or normal substances. Second point, strength. Plastics are lightweight, strong and durable. Especially we have seen in the case of thermosetting plastics, they're very strong and durable, long lasting. But if the wood materials and metal materials, they are not long lasting, they are not lightweight. For wood and metal objects are heavy, but these plastics are lightweight and strong. They are slowly replacing metals in making parts of machines and bodies of objects like cars, washing machine, etc. So nowadays, instead of metals, we can use plastics for making many of the appliances like washing machines, for making the parts of or bodies of objects like cars. For example, in this figure we can see that this washing machine is made up of plastic, this car is made up of plastics. So slowly we can replace metals in many of the field because of the properties like strength, lightweight and durability of plastic. Next, thermal conductivity. We have seen this property under thermosetting plastic. Many of the thermosetting plastics are insulators of heat, means they do not conduct heat. So thus they are used for making dishes used in microwave oven and handles of cooking utensils. They are used in insulating materials in refrigerators and air conditioners. So many of the thermosetting plastics like melamine, they do not conduct heat. They are insulators of heat. For example, handles of cooking utensils and dishes, they are made up of plastics. This handle of this pan is made up of plastic. So because of that reason, what happens, this plastic will not conduct heat, and means it is insulator of heat. So then it is easy to use this cooking utensil. Otherwise, if it is made up, this handle is made up of a conductor material like metal, then we will not be able to handle this cooking utensils. Similarly, many of the dishes, plates are made up of plastics, mainly thermosetting plastics, because they are insulators of heat, they do not conduct heat. Next, electrical conductivity, and similarly some of the plastics are insulators of electricity, like we have seen bakelite, thermosetting plastic bakelite. This bakelite is used for making the coverings of wires, for making the coverings of electrical appliances, and for making electrical appliances. This bakelite is used. Why? Because this bakelite is insulator of electricity, and this wire and this electrical appliances are exposed to electricity. So when you use it, when you use the wire or this electrical appliances, we should not get electric shock. So for that, this material, this covering should be made up of what? Insulator of electricity. So if instead of that, this insulator, instead of this plastic, if you use any other object which is a conductor of electric current, we will definitely get the electric shock and it cause death. But this electrical appliances and bodies of electrical appliances, and for covering wires and cords, we use plastics like bakelite because it is insulator of electricity, so then easy to handle. We will not get electric shock. So this is the property of electrical conductivity. Next one, inexpensive. Then compared to metal, wood, glass materials, the plastics are not expensive. They are very cheaper than, they are less expensive than other materials like glass, wood and metal. So these are the properties like inexpensive, electrical conductivity, thermal conductivity, strength, resistant to chemicals. So these are some of the important properties which make the plastics popular in our life.